All right, students, welcome to your last unit, unit number 19, where we're going to be discussing hypothesis testing and research in the media. Looking forward to this subject. So our objectives today is first, we're going to develop some terminology associated with hypothesis testing. So just some general terminology we'll be talking about that you've seen before, but I'm going to reiterate it again. Then we're going to walk through the steps of proper hypothesis testing. And this is going to be really essential for when you actually go out into the field and start developing hypotheses so that we can actually test them to say, was this hypothesis confirmed or rejected? And lastly, this is just going to be a quick run through of media and research. I didn't really have too much on that topic, but I wanted just to have something because I said I would do it in the syllabus. So what is hypothesis testing? In hypothesis testing, we're actually interested in statistically showing whether a hypothesis was supported or not. So this isn't a matter of, whether you believe it was supported or not. It's actually showing statistical data to support it or not. And what we'll be doing is doing something called rejecting or accepting, something called a null hypothesis, which I'll be talking about into the next slides. And what we're doing is we're comparing an alternative hypothesis to a null hypothesis to determine what level of significance we have. And whenever you see the term p-value, that's really all that this p-value is doing is comparing your alternative hypothesis to the null hypothesis and really stating how likely is it that we got this result given the null hypothesis was true. If the null hypothesis was true, then what will we say? And I'll go into null hypothesis, what that means in the next slide a little bit more. And I also wanted to just say, this is a brief introduction to hypothesis testing. For those of you who will be continuing to Psych 350, this is going to be extremely helpful. But it's not just for the students that are going into Psych 350. This is really for everyone to talk about what are the proper methodology and steps when we're conducting a hypothesis test to statistically show whether our hypothesis was supported or not. I want to talk about some terminology here. The first one is a phrase that I brought up in the last slide, which was null hypothesis. A null hypothesis is essentially stating that there's no difference or no relationship or some sort of effect in a population. So what you're saying is whenever you state a hypothesis, this is just saying, yep, nope, no matter what we say, this is not going to be true at all. An alternative hypothesis, on the other hand, is the assumption that there is a difference or there is a relationship or an effect in the population. So this is taking your hypothesis and saying, yep, this is true. What I stated is true. This is in comparison to what the null is. This is what we're seeing, so it must be true to some statistical degree. We have confidence that it's true. Next, we have statistical significance. And note that I state the word statistical significance because we're using some statistical properties to determine whether or not we have statistical significance or not, whether this is significant from a statistical standpoint. But essentially, what a statistical significance means is it's a researcher's assessment of whether a result from a sample could have come from a population in which there is no association or no difference. So when we get a sample that is extreme, then it would rarely be found in that population and it is said to be statistically significant. And we measure this via p-values or what you're going to be learning about later, which is called critical regions. Lastly, I want to talk about the term alpha value. An alpha value, which I'll be going into more detail a little bit later, is a value that we determine in advance at which researcher decides whether or not the p-value obtained from that. So remember what a p-value is, that's p less than 0.05, obtained from a test statistic is low enough to reject the null hypothesis. So when we're rejecting the null hypothesis, we're retaining the alternative hypothesis and saying, okay, we accept that there is some sort of difference in this than we would have seen if this was part of our population overall. So that alpha value is just a value we're setting up beforehand to say this is the degree that we're going to say is a significant effect so that we can say that there's a difference from some sort of independent variable or predictor variable that we are able to say with some degree of confidence that this is different than a population in which there is no relationship or no effect. We'll be going through 8 different steps today for hypothesis testing. The first one is one you already know how to do, which is formulating your general hypothesis. Next, we're going to state the null hypothesis, so you're going to get a little bit more detail about what a null hypothesis is. Then we'll state an alternative hypothesis. Then we'll set our alpha value. Then you'll notice this precedes collecting data, so all this stuff should be done before you even collect your data. Then we'll calculate a test statistic. We compare test statistics to something called critical regions, which I'll go into a little bit more detail later. And then we're able to actually start drawing conclusions from our statistical hypothesis testing steps. And really, our drawing conclusions are going to come from steps 6 and 7, in which we actually calculated test statistics and then compare that test statistic to the critical regions. Now, we're not going to get into detail today about how to actually calculate these test statistics, but rather we're going to have kind of a general understanding of what a test statistic is and how it's used to, compare to these critical regions. So the first one is formulate a general hypothesis, right? We've already done this before. I actually copied and pasted some of this from previous slides in which we say we get a population of interest who we use some sort of predictor variable or independent variable, will have some sort of outcome or dependent variable, and compare it to a comparison group. So simply, we create a hypothesis based on a theory and some sort of research question, and we start thinking in this line of, because of some theory, this should cause Y. So X should cause Y in some way, and we use our research questions to kind of phrase it overall. And then remember just to include all those aspects of a general hypothesis. And that becomes really important for when we actually get into talking about stating null and alternative hypothesis testing, because you need all those aspects in there in order to actually test the hypothesis statistically. Our next step is to state the null hypothesis, and that can be stated by this symbol here, which is H sub 0, which is stating simply that we are not expecting to see an effect. So all you're saying is you simply rephrase a hypothesis so that you indicate that there's no effect. So you had your general hypothesis and already, right? So let's run with the hypothesis of saying, I hypothesize that adolescents, when ran through a cognitive behavioral therapy, will have reduced levels of depression as compared to those who do not. So that's my general hypothesis. So what I do is I restate that hypothesis to say that you restate it so that it says, I believe that, or I hypothesize that adolescents that run through cognitive behavioral therapy will experience no difference in their levels of depression as compared to a group of teens who do not go through the therapy. So what I'm saying is, and I know it sounds kind of antithetical to what you've learned, but you want to actually have this phrase written out saying there's a possibility that they will not experience any difference is in their levels of depression. And we can also express this mathematically when we simply say the mean of our depression levels for mean 1 is equal to the mean of the depression levels of mean 2. And that's all we're stating with a null hypothesis, that there is no difference. Alternatively, we state the alternative hypothesis, which is essentially the differences between which is the one that really is generally what our general hypothesis is getting at. Now what we're doing is stating that there is some sort of an effect. So we simply rephrase the hypothesis so that there is an effect. So now we're saying there will be a difference in the mean of my two groups. Or you can indicate it in a way that, mean 1 will be higher than mean 2. Group 1 will have some higher score than group 2. And this additionally can be expressed mathematically depending on how you do it. So based on my general hypothesis, the alternative hypothesis is going to sound very similar. In fact, it's going to be just about the same. But it's important to kind of distinguish that there's a difference between the general hypothesis and the alternative hypothesis, because Now with the alternative hypothesis, we're actually kind of formulating it mathematically. We're saying, so in my original general hypothesis, what I stated is that adolescents who run through cognitive behavioral therapy will have lower scores on depression as compared to those who do not. And you'll see this is a sense of why it's so important to have this comparison group. Because if we didn't have that comparison group, then we wouldn't be able to mathematically formulate this out. It would just be mean 1 and we wouldn't have a mean 2. So that's why I really was a stickler before about having this comparison group. So in our general hypothesis, what we're stating here is actually, if you look down at the very kind of bottom of the slide, which indicates the alternative hypothesis and stating it mathematically, what we're saying is that, let me go and get a pen here. What I'm stating is that mean 1, so a group of our individuals that ran through the cognitive behavioral therapy will have lower levels of depression as compared to those who did not run through the depression cognitive behavioral therapy program. So what I'm stating is that mathematically I am predicting that mean 1 will be lower than mean 2. I could have indicated no direction as well, indicating that I just think there will be a difference in the means, but here I mathematically stated that the mean 1 will be lower than mean 2. And you can have multiple means in here too. If you have multiple independent variables, multiple means that you want to compare, you can do mean 1 is less than mean 2 is less than mean 3 and so forth, is really what you're saying. But here I'm actually indicating there's a direction. So the mathematically speaking part of it is where I am actually indicating that mean 1 will be lower than mean 2. Next, we do something called setting an alpha value. And what this alpha value is, it's actually determined by, it's actually stated with this Greek letter alpha. But what we're doing here is before we even collect our data or do any sort of analysis, we state what is going to be our value of significance. What are we willing to accept is a probability that we are wrong. Remember, what we're doing here is comparing the alternative hypothesis to the null hypothesis. And what we're stating here is, because from our test statistic that we will obtain later, it will give us a probability that we are wrong, that our alternative hypothesis is wrong and our null hypothesis is correct. We need to give it a level of saying, well, we know we're not going to be 100% positive on this, so we need to accept what we are going to say. And this is indicated oftentimes by the p-value. And the p-value is simply stating what is the probability that you're wrong or that the null hypothesis is true, even though you set an alternative hypothesis. So normally we set this at 0.05, so stating that there's a 5% chance that we're wrong. You'll see that in a lot of research, but in terms of other research such as, let's say with medical research where they're comparing like a placebo to an actual medication or something like that, they want to be really positive they're correct. So they'll set their alpha value to something lower like 0.01, saying we're willing to only accept the 1% chance that we are wrong. But the most important thing here is that you state beforehand what level of probability you are willing to accept to be wrong. And we'll see later how this ends up happening. We get this probability outcome. But just think in your head right now, when I'm setting an alpha value, I'm setting what % chance I'm willing to accept that my alternative hypothesis is correct and my alternative hypothesis is how much we fail to reject the null hypothesis is what we'll be stating. Now for this next step, I'm not really going to dig into it too much because we've already talked about all the strategies to collecting data, but your next step is to actually collect your data. Now it's very possible you're working with an archival data set and you already have the data collected or something like that. It's okay, but just the entire purpose is that you really hadn't looked at your data prior to getting to this step where you set your null hypothesis, your alternative hypothesis, and set an alpha value prior to actually looking at your data. It's a really important step that you actually you collect the data after you've set all of these things, or essentially you just haven't looked at your data or analyzed it in any way prior to setting up these hypotheses. Really, I find that whenever I go into research and we're at a research meeting, before we even collect the data, we're already hypothesizing and setting up our null and alternative hypotheses before we even start data collection at all. But this is an essential step that we need to take into account. Essentially, just don't look at your data prior to doing the previous steps. Next, we're going to do something called calculating a test statistic. Now, the great thing is you've actually already learned about these previously, in which we talk about the t-statistic, the f-statistic, the chi-square statistic. What these do is they essentially provide us the ability to capture the probability of obtaining the value we did. So for example, if we did this running with the example of adolescence, cognitive behavioral therapy, and levels of depression, what we're doing here is saying, okay, we ran through, we collected our data, we've already set our null and alternative hypotheses. What we'll be seeing now is how different were our groups from each other. And that's what these test statistics tell us, essentially, as we say, how different was our group one, which is those that ran through the cognitive behavioral therapy, as compared to the group two, which is the adolescents that didn't run through cognitive behavioral therapy. And all this number tells us is the degree of difference between them. And there's different test statistics depending on which test you do. So you can get a Z statistic. If you're running a T test, which is comparing two means, it's saying how different are those means from each other. If you're comparing multiple means with each other, you get the F statistics, which is saying how different is 3 or more means from each other. And then we have a chi-squared statistic, which is saying if you had two nominal variables that you're comparing with each other, what is the basis of the frequency differences between them is really all we're saying. And that's what it's capturing with these test statistics. So when you think of a test statistics, just say it's analyzing the degree of difference between two or more obtained values. And that's what our test statistic does. And what we do with this test statistic, now this next step is where we get a little bit more into the statistics of it all. And we're not going to dive too deeply into the statistics, but a matter more of what we'll be talking about is how we can actually determine whether or not we reject the null hypothesis or retain the null hypothesis. And remember, when we retain the hypothesis, the null hypothesis, it means we didn't find any difference between our groups. Here is where our alpha value that we set earlier comes into play. So based on our test statistic, which really will get us our p-value, we'll determine whether or not we would choose to reject the null hypothesis, which is that says there is no difference, or retain the null hypothesis. In this case, what we'll be doing is comparing what our p-value was, essentially. And remember how we set our alpha value at p at 0.05 or 0.01, which is saying the 5% chance that we've gotten the result we did, given the null hypothesis was true. All we're doing here is just saying, did we obtain that value or not? And these are called comparing it to the critical regions, because with the test statistic that you got, it will set it onto this chart whether or not that's contained a p-value less than 0.05 or 0.01, whatever you set your alpha value at. Now, like I said, we're not going to dig too much into the statistics of all this, but just know out there, and it's okay if you don't completely understand this in full, but what we need to understand is that your test statistic will determine whether or not you choose to reject or retain the null hypothesis depending on what you set your alpha value at earlier. And that's really all there is to this. And then the last thing we need to do is draw our conclusions. And really what we do is, this is kind of similar to the last step, but all we're saying is, do we choose to accept the null hypothesis or reject the null hypothesis? And essentially what you're saying is, if we reject the null hypothesis, we're saying that there's a difference between our groups that we did. Or if we retain that null hypothesis, we say there is no difference between our groups and everything should retain the same. That essentially what our treatment was of interest was, so in this case, the adolescent depression through those that did cognitive behavioral therapy, was there an effect of cognitive behavioral therapy on the outcome of depression? And if our critical region, if our test statistic said that yes, it was above that, then we choose to draw our conclusion saying yes, cognitive behavioral therapy has some sort of effect on teenager depression or adolescent depression. Whereas if we didn't see our test statistic hit that, then essentially we would say, no, we didn't hit that level of rejection. Therefore, there is no effect of cognitive behavioral therapy on the outcome of depression. Now, I wanted to go ahead and also talk about something called type 1, type 2, and type 2 errors. Essentially, you should have read about this in your book when we read about the statistics section. However, I decided to wait a little bit to talk about it because it relates so much with hypothesis testing. Essentially, what we're saying here is that when we do this hypothesis testing, there's two types of errors that can occur and that you set yourself at risk for every single time you run a hypothesis test. The first one is really called type 1 error. This is where we reject the null hypothesis even though it was indeed true. So in other words, what we're saying with a type 1 error is that we said there was a difference between our groups, but in reality, the truth is, from the population perspective, there was not a difference between our groups. And the way that you can change this in order to make this so that you have less chance of getting a type 1 error is by reducing that alpha value that you originally set. So setting it from a 0.05 rejection rate to a 0.01 rejection rate would make it harder to get a type 1 error. What that's saying is that it's harder to reject the null hypothesis when you change your alpha value to a lower value. Next, we also have something called a type 2 error. This is the exact opposite problem. This is where you fail to reject the null hypothesis even though it was false. So essentially what we're saying is there was a difference between our groups, but we didn't set that. And the way you solve this problem, it can be quite the opposite actually. By changing your alpha value so that it's higher would make it easier to reject the null hypothesis. But you notice the trade-off here, right? With a higher alpha value, so that of like 0.10 as opposed to 0.05, would make it harder to get a type 2 error, but it makes it easier to commit a type 1 error. Therefore, when you're setting your alpha value, you're doing a trade-off every single time. And there's a few other things associated with things like sample size that can work with this as well, and how large the effect is in the actual population that works with this as well. We're not going to dig too deep into that, but just know that your alpha value is one of the things that can determine whether you're more likely to commit a type 1 error or a type 2 error. Now, you'll know that oftentimes we set our alpha value to 0.05. That is completely arbitrary as to why we set it there, but it just seems to be an agreed upon thing among at least psychological research as to whether we choose to set our alpha value at 0.05. So we are okay oftentimes with the understanding that there's a 5% chance that we were wrong in our interpretation. So 5% of our results, if we ran 100 tests, 5 of those results would oftentimes commit a type 1 error is what we're saying. So, are we okay with that? 100 times, 5 of those results being wrong. So, and we only have one of those studies. So there's a there's a 5% chance that one of our studies committed a type 1 error in there. Is that something that we're willing to be okay with? Well, it seems like a lot of research is okay with that, saying that, you know what, we're okay with the 5% chance that our research statistically was committing a type 1 error, essentially. Whereas other things like in medical research, sometimes they're only okay with a 1% chance, essentially. But it's all how you set your alpha value that will determine whether or not you have that type 1 or type 2 error. And again, there's other things like increased sample size. The higher your sample size is, the less likely you are to commit a type 1 error. And additionally, that helps with type 2 error as well. How large the effect size is also another thing that can do it. So if your effect size is very large, so if we expect to see a large difference between our groups, which would be the effect size, then we would be able to say that that has something to do with type 1 or type 2 error, whether it improves or deproves it overall. But really, just keep in mind, when we're doing hypothesis testing, there's always the chance to have a type 1 or type 2 error. Next, I'm going to do, this is going to be a really short lecture. Originally when I planned this a long time ago, I thought I had a lot more content on it than I did, but we're going to end it off with a really short lecture on research in the media to talk about. Overall, I just want to talk about the public and the media, but overall, the media is a great resource and it provides the opportunities to educate the public on science, whether that be biological sciences, medical sciences, chemistry sciences, or psychological sciences. The media has a great responsibility and a great way of portraying that to the public and in making it so that it's easily digestible for the public as well. Additionally, it's no really secret that mass media is the primary source of the public's understanding of and receiving of scientific information. So it's really important that they take on this responsibility to relay the information. And you have to think about it. It's not like the public is going out and reading scientific journals. I mean, in all honesty, sometimes scientific journals can be a little bit dry, even though they contain all the information we need and they're extremely important. They're a little bit dry, and the media has a way of portraying it so that's actually interesting to an audience. And I want us to know, like, mass media comes in many different forms. I mean, we're talking newspapers, the television news, documentaries, podcasts, and lots of other ways, radio talk, and lots of ways that the mass media can portray science. However, the problem that comes into hand when the media is portraying science is determining which scientific studies are most strictly important to portray. There seems to be a disagreement between science and between scientific literature and the media as to what's important. And oftentimes, what the public media, what the mass media does is kind of what's the most interesting and not necessarily what's the most important to talk about. Really, I'm just going to end off the slides here and say, the pros and cons of the media. So overall, they're able to get a large amount of information to the public. And additionally, they get the public interested in scientific events. However, the problem oftentimes with mass media is that they don't accurately report on scientific reports. This is where you get these information like, eating a piece of chocolate every day is good for your health, or something along those lines, where it was really just one finding in a large body of scientific literature, but they took this one thing and reported on it. But it's not necessarily true, and in fact, they might not even go through the steps of talking about this in terms of the process or hypothesis testing like we just learned. So really, when you're reading these mass media articles, it's important to be wary of what they're coming back. It's not to say all mass media is wrong, but essentially these reporters don't necessarily have the same scientific rigor that a scientific journal has, and that goes through these hypothesis testing. And the reason I wanted to bring this up in the end is because now, hopefully from the end of this class, you have this ability to know how to look up scientific articles and research them and read through them with at least some scientific knowledge and understanding that the what is going on in a scientific paper, and you don't have to rely so heavily on that of the mass media, because the mass media has a tendency to mistangle information, and although it may not necessarily be wrong all the time, but it can make it so that some information seems much more large and has a larger effect size than it really does. But now you, as a researcher, can read through a scientific report and make an understanding of, oh, see, the media reported it one way. However, the scientific journal seems to encompass a different body of literature. Additionally, mass media doesn't seem to have a focus on things like replication or like what makes a valid study or not, or whether or not the study had external validity. One study in the lab that only tested about 10 participants, and all those participants lost weight from eating chocolate. Is that necessarily an externally valid study? Were they able to generalize that to a broader population? Now, the hope is that a scientific journal will talk to you about the external validity of the study. However, it's not the responsibility of a journalist out there to talk about the external validity of it. So some information might be swayed. So when you're reading these mass media articles, it's important to take it with a grain of salt and do your own research beyond that. It's very possible that the mass media article could have been correct, but you now have the ability to go beyond that of a media article to test and determine through scientific literature reviews and understanding of what statistics in science are to get that information. So really, it's a great resource to have the media, but it may not always accurately reflect what is truly going on in science, and may not accurately reflect what is truly externally valid in the scientific literature. So overall, from these two kind of different lectures that you got really quick here, but I want us to note that hypothesis testing is an important aspect to answering research questions. Following those steps gives us more scientific validity behind whether or not we have a true aspect of rejecting the null hypothesis or retaining the alternative hypothesis. It's a very specific process, but with that, you have that potential for type 1 and type 2 errors, saying that, given we set our alpha value at 0.05, we still have a 5% chance of seeing this result, even though it's totally possible that result's not true or not. Because with statistics, remember, we're only seeing a sample of the population, and we don't have the entire population to look into. Therefore, we need to take with some concern why. And this kind of wraps up and brings everything together, because that's the importance of replication as well with these statistical procedures, is that we need to replicate all of these studies as well, because it is very possible that the results we're getting fall into that 5% range of scientific studies that will find a significant result, regardless of whether or not the null hypotheses are true. It just so happened that your results were that you pulled from the sample you pulled from your population ended up being in that 5% range, which is just unfortunate and unlucky, but 5% of the time it can happen. And that's what we're wondering with these scientific studies is, are we falling into that 5% category way too much? And then lastly, simply put, there's pros and cons to research in the media, but I believe that you are good enough scientific researchers to be able to go beyond that of the media and make your own opinions based on the scientific literature. And that concludes the Psych 250 class. I want to thank you so much for listening to my lectures. If you made it this far, thank you so much. If you have any questions at all, please feel free to email me. And that goes beyond that of this class as well. I know that this was originally supposed to be an in-person lecture. However, COVID kind of had different plans for us. But if you ever happen to see me around on campus when we get back onto campus, feel free to stop by and say hi. If you see me in my office, I would love to get to meet you in person someday. I know I've had some email and chat correspondences with many of you, which I thank you so much for your questions and your inputs that you provided me. But overall, thank you so much for taking the time to listen to this class, and I look forward to seeing anything that you do in your oncoming future.